¿Qué es la que hay, mi gente? Welcome to Cruz Learning, where it's just that easy, with your favorite host, Master Cruz. And today we're going to talk about graphing linear functions. So the first thing we need to learn is this amazing equation that it's called y equals mx plus b. And I promise, if you understand that by looking at this equation, you're able to see the slope, which we used m to represent, and you're able to see the y-intercept, which is b, then you will be able to graph these things very easily. This is called the slope-intercept form, and is the most common form of the linear function. Now, as a quick review, slope is the rate of change. If you have any questions about the rate of change, please look at my video called Rate of Change so that you understand a little bit deeply what is the slope. But here we will talk about the slope, especially when we are graphing. So when we graph, there's three steps that we want to follow. We first plot the y-intercept, which is b. Then we start from the y-intercept to use a slope, and we count rise over run. So run, right? So the reason why we plot first the y-intercept is so that we start counting from there, and I'm going to give you an example in a second. The third step that we're going to do is the same thing that we did when we were in kindergarten. We're going to connect the dots and check the slope with the equation. So the first rule of thumb when we're graphing is that everything that we do, we're going to do it from left to right. So if my graph is moving from left to right, this is increasing, right? And this yellow arrow, it's from left to right. So you understand that this is the left and this is my right. So as I move along this line, it's going up. Therefore, the slope is called to be increasing. This is a positive slope. M, remember, is slope. If I'm moving from left to right along the line and my cursor is moving down, or your pencil's moving down, then you're decreasing, which means the slope is going to be negative when you see the equation. And if you see a horizontal line, well, the word horizontal has two zeros in it. Therefore, this is called constant because it's not increasing or decreasing, and the slope equals 0. We will see an example of all of these. So here we go. First, we're going to graph y equals x plus 3. Well, the first thing that I want you to have in your mind is y equals mx plus b, right? If this was, and we could write over here, y equals mx plus b, right? And I ask you, well, what's b? Well, it's clearly easy that b is 3. And our first step on the top was to plot the y-intercept. So the first thing is that I already have a graph over here. I'm going to go to the y-axis, and I'm going to plot a point at 3 because that's 3. So I'm going to find wherever 3 is, which is right here, and I'm going to plot a point. I just plotted the y-intercept. So this number all alone by itself goes straight here. Then what is m? Well, in this case, you may be tempted to say that m is x, but m is not x. X just lets you know, hey, look at the number in front of me, and that's m. In this particular case, because there is no actual number, there is an invisible 1. There's always a 1 because you have 1x. And m is a slope. And in the previous chapter, we learned that m, which is slope, is rise over run, which means it's always a fraction. But 1 is not a fraction. So how can we make 1 a fraction? Because the current slope in this problem is 1, right? M is 1. Well, to make it a fraction, we just put it over 1. Literally, we write it 1 over 1. And whatever number that is, you write it here in yellow, and then you put it over 1 if it's not a fraction. Well, this tells me go up 1 and run over 1 to the right, because everything we do is from left to right. So that says go up 1 and over 1, and you're going to find your next point. My next point is right here at 1, 1,4. And then technically I could connect these points, and that's it. That's the correct answer. The problem is I want to be very, very specific. I want to make sure that I'm going through the correct points that I'm supposed to go through. And how can I double check that? Because my graph may not be perfect. Well, that's when we create a table. So what I just show you is actually a shortcut. If you know how to do it, you just do it. You plot the y-intercept and you count rise over run. But if you're not sure, then we're going to do what we always need to do every time I give you an equation, and that is create a table. So with me right now, you're going to create a table so that we could find points, more points to plot along this line to make sure that it's going to the right place. Well, because they didn't give me any values of x, and x is my input, I'm always going to choose those values if they don't give them to me, right? So the values that I'm going to choose are going to be the easiest numbers in the world, and these are the easiest numbers in the world: -2, -1, 0, 1, and 2. Every single time that I choose numbers throughout a table, for the most part, these are going to be the easiest numbers. So what I need to do is plug in these x values inside of this equation. So, because I want to find out what the y value is, I want points. So what I'm going to do is that I'm going to use what I'm going to do 0 first, right? So I'm going to say, okay, well, y equals, oops, there's a glitch here. Y equals x plus 3, which really means that I'm going to substitute that x and I'm going to put a 0 instead. Okay, actually, I'm going to work this down so that it's consistent. So instead of x, I'm going to write down a 0, and that's going to be 0 plus 3, 0 plus 3, and 0 plus 3 is just 3, right? So this gives me a point. When x is 0, which is what the color that I just plot, right? The 0 that I plotted, then y is 3. That's a point that goes on my graph. So when x is 0, y is 3, and that's a point right here. I can repeat the process with every single number. So now I'm going to repeat the process with 1. I'm going to come up here and I'm going to say, well, y equals, but instead of 0, I'm going to plug in 1 plus 3, right? 1 plus 3, which really equals 4. So that gives me another point. When x equals 1, y equals 4, right? So I go here, and this is 4. If you repeat the same process and you plug in number 2, you're going to get 5. Okay, if you want to check it, you can, but right, if I plug in 5 here, 5 plus 3 is just, sorry, now 2 plus 3 is just 5. What happens when I put -1? If I substitute -1 in here, right? So -1 plus 3, and I'm going to plug in -1, when different signs subtract, right? So that equals +2, the same sign, add and keep, different signs subtract, keep the sign of the higher number, then you'll be exact, yay. And if you find a pattern, you can quickly see this is going to be 1 up here, and then I'm going to plot the points. So the first point that this says is 0, 3. Well, that was the first one that we found right here. And look, that's the first point that we actually plotted. That was our y-intercept. If I go down, I find 1, 4, which is perfect. That is 1, 4 right here. And I can keep going one more. It says 2, 5, which means there should be another point at 2, 5 somewhere up here. So it looks like our line, it looks good so far. Let's go the other way. Let's go negative. So when x is -1 and y is 2, I go to the x-axis and I find -1. So I move 1 to the left, and then 2 up. I should have a point right here, and I do. That's perfect at 1, 2. And there should be another one at -2, 1. So -2, 1. So even though my line is not completely perfect, right? My graph is not completely perfect. It's very close to what it needs to be. So this is the line in case that you didn't know just by the 2 points, and you could graph it completely. All right, so that's how you graph. You first create a table, and then you plot the points and graph. So let's do example 2. What happens when you're given an equation, and the equation does not look like y equals mx plus b? Well, we can rewrite it as y equals mx plus b, very similar, knowing our techniques to solve linear equations. So what we're going to do is that we want the x on the right? We want to make sure, I'm going to write this. I want this to look like y equals mx plus b. So that y needs to be all alone by itself. So over here, I'm going to draw a line, and I'm going to move. I'm going to move things from the left-hand side. Looks like I'm going to move the x term. You always move the x term from one side of the equal sign to the other. And we learned we could do that as long as do one thing. And that thing is change the signs. And this is going to turn into a -4x. I am not moving the 2y, so I'm just going to leave it positive 2y. I'm leaving the equal sign right there, a line, and I'm not moving the 8 from one side of the equal sign to the other. So I just bring down the positive 8, because that's a positive 8. I need to write plus 8. Well, I'm almost done, but I'm not done because y is not by itself. It's being multiplied by 2. So the inverse operation of multiplying by 2 will be to divide by 2. Now I have to divide every single term by 2. And when I do that, I'm going to get that y equals, here's that glitch again, y equals negative 2x, because 4 divided by 2 is 2, and it's going to be negative, and 8 divided by 2 is 4. So now when I look at this, this looks like y equals mx plus b. So that's perfect, because this is what I'm going to graph. I'm going to graph y equals mx plus b, right? So I can do this two different ways. The first way is create a table, right? So you could create a table. That's the longer way, create a table. And then the second way is using the techniques that I gave you in the top. But we're going to use the techniques that I gave you in the top first to prove that this does work. And then we will graph, we create a table, or we'll create a few in a table to make sure that you're able to do all of them. Make sure that you understand how to do this. All right. So we're going to do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Here we go. So when we are here, the first thing that we notice is the y-intercept. Now, hopefully you can see the y-intercept is the number by itself, and that number is positive 4. So then I just go to the y-axis and I plot a point at positive 4, which it will be actually right there. So that's going to be my y-intercept. Boom, I already have a point. I just need one more. What is the slope of this line? Well, hopefully you will be able to see that the slope of this line is negative 2. So if I write on the side m equals negative 2, again, I need rise over run, but this is negative 2. What can I do to make it a fraction? Well, I just put it over 1. And this will be rise over run, rise over run. So what does that mean? Well, before the slope was positive, so we went up, but now the slope is negative, we need to go down. So I'm going to go down, I'm going to count down twice from the y-intercept. I already plotted that point. A common mistake is that people go to the center and count 2 down. That's a mistake. You go to the point that you already plot and you count 2 down, and then you run 1 over to the right. Now, even though it's negative, you always move to the right because the negative is just making it go up or down. At this point, I have 2 points. And if I want to, and I want to be a little bit more precise, I can go down to from here and 2, right? Down 2, right here. And then you run over 1. So let's do that one more time. You go down 1 and 2, and then you run over 1 again. And there's another point right here. I can repeat the process. Go down 2, over 1. There's going to be another point right here. And then I could just connect the dots to make a straight line. Okay, that line, even though it's not perfectly straight for me, and that line, if you plot it in a graph that it's well drawn, then it's going to be a straight line. How can I find points for this? How can I find point for this? Because I need to be able to complete a table. So let's complete the table to check if those points that I got are correct and what other points we can add. A table is always x comma y because it's in alphabetical order. Also, you always find out that you have an x and then you find out y. So that's the reason why that's always x comma y. So here we go. Easiest numbers in the world, -2, -1, 0, 1, 2. I'm going to plug them in. We're going to plug in a few. We're going to plug in -2 first. Okay. So I'm going to say -2, open parentheses, plus 4. But instead of x, I'm going to write down what x is, which is in this case, -2. So just combine like terms. -2 times -2 is positive 4. And 4 plus 4 will be 8. So this point is way out of my graph right now, but it makes sense. When I'm at -4, this should be all the way up here somewhere at 8. And that kind of makes sense. Let's try 0, right? If we try 0, then 0 plus 4, right? Because it's -2 times 0 plus 4. I plug in 0. Anything times 0 is always 0, so that cancels. And this is just 4, right? So that gives me the point 0, comma 4, 0, comma 4, because I plug in 0. This gave me the point negative 2, oops, negative 2, comma 8. And then so I put the 4 right here, 0, comma 4. Let's stay consistent with the colors, 0, comma 4. So there we go. And if we plug in positive 2, and that's the last one that I'm going to plug in, okay? If we plug in positive 2, we should get 0 because according to our graph, when we counted rise over run, we got 0, but let's double check it. All right, so if I plug in positive 2 here, I get that negative 2 times positive 2 is negative 4, and 4 plus 4 is 0, so this is 0. You should be able to fill in the blanks with the other one. This will actually be 6, this will actually be 2, and this is 0. I know that because you're going down by 2s. As you can see, that's the pattern, because my slope was negative 2, and my slope is telling me, hey, go down by 2s. So 8, 6, 4, 2, 0. Hopefully you can see the pattern, and that's how you graph them. Now, there is one last type of graphs, and you need to be able to know how to graph. And those are horizontal or vertical, okay? Vertical lines. So how do we graph these? Very simple. If you look at y equals 5, you could clearly see that 5 is a number by itself. It doesn't have an x, so that is the y-intercept. So I'm going to go to y, the y-axis, and I'm going to mark 5. But because there's no x, okay, that means that m was 0 because there's no x. It's just y equals 5. All you have to do is go and extend that tick mark. Now, I drew the tick mark. The tick mark is the mark that you do, right? The mark that you make to mark the number 5. So this red mark is the tick mark, or that white mark is the tick mark. All you have to do is come here and extend it. So if I extend that tick mark right and to the left, okay, that makes a horizontal line. And that line, like we saw at the beginning, has a slope 0, and it's called a constant slope, okay? For the vertical line, well, what about if I ask you to graph x equals negative 3? Well, x equals negative 3, it says x this time, it doesn't say y. So I have to go to the x-axis and find negative 3, and I draw a tick mark right there. And after I draw my tick mark, all I have to do is connect them or make it longer. So that's what I'm going to do. I'm going to go up and I'm going to go down. Extend the tick mark. Make the tick mark longer. That's all you have to do. Just make the tick mark longer. This will make a vertical line, which is not a function because the x's repeat. Now, because it's not a function, then the slope here is on the function. So that's what you have to know about graphing y equals mx plus b, which is the slope-intercept form. If you need additional help, please visit us at virtualmathmasters.com/free session so you can get your free session and we can help you individually. This was all for today. My name is Master Cruz, and it's just that easy.